Avis, welcome to Avis Mathematics channel. As what we have learned in primary school, we know how to change from decimals to fraction. For example, 0.7 is equivalent to 7 over 10, right? But today I'm not going to touch about this. I'm going to touch about what recurring decimal is and how can we change recurring decimals to fraction. Okay? Without any further delay, come, let's look at the following steps. Let's start now. For those who are not sure what recurring decimal is, let me explain it here. So if let's say I have 0.7 and on top of 7 here we have a dot. So meaning that this 7 is repeated for many times. We can write as 0.7777 and so on. Okay? So how do we convert these recurring decimals to fraction? It's very easy. First step is we need to let x equals to 0.7777 and so on, right? Next, we times this x with 10x. Okay, we need to find 10x. So 10x, we know that this equation, the first equation we times 10, we can move the decimal 1 to the right hand side. So it will become 7.7777, right? Okay, so next question you need to ask yourself is, can we minus the 7 here after the decimal place? 777, can we minus with 7777? It's very obvious can, right? We can minus it completely. So meaning that we can take the second equation minus the first equation. We will have 10x minus x, we have 9x. Alright, so and then 7.7777 minus with 0.7777, we get 7, isn't it? So eventually our answer will be 7 over 9. Okay, so this recurring decimals of 0.7777 and so on is equivalent to 7 over 9. Alright, our next example here. So if I give you, what about 0.23? Okay, 2 and 3 are repeated. Okay, so 0.23, so we can let x equals to 0.232323 and so on, right? Next, as usual, we find 10x. So 10x will be 2.323232. Okay, so we times the first equation with 10. Okay, so we know that this 323232 cannot minus with 232323 completely, right? Meaning that we cannot make it to 0 at the back here, isn't it? So if we cannot make it to 0, so next we need to find 100x. 100x is, so we move the decimal place 2 to the right, so become 23.232323 and so on, right? And from here we know that this equation and this equation we have 232323 at the back, and the first equation we also have 232323 at the back. See? So meaning that we can minus these two equations. So 100x minus x, we have 99x, right? And then this equation minus with the first equation, we have 23. So eventually we have x equals to 23 over 99. Okay? So 0.23 is equivalent to 23 over 99. Okay? So far so good, yeah? Next example, what if I have this one, 0.084, the dot is on top of 4, meaning that this is equivalent to 0.084444, right? And so on, right? So first step, we can let x equals to 0.084444 and so on, right? Next, 10x is equals to, so move the decimal 1 to the right, so it becomes 0.844444. Okay, so this and this we cannot make it to 0, isn't it, at the back after we minus it. So if we can get minus, so next one we need to keep on doing. 100x is what? So 100x, we need to move the decimal 2 to the right hand side, so become 8.444444. Okay, and these three equations we still cannot get the same at the back here, so we need to keep on moving. What about 1000x? So 1000x is, so you need to move the decimal 3 to the right, so it becomes 84.44444, right? So from here, so we can see that this one and this one at the back are the same, right? So we can make it to 0, cancel it. Okay, so meaning that we can take 1000x minus 100x will give you 900x, right? And this minus this, we have 76, isn't it? So our final answer will be 76 over 900. So if we divide these two numbers by 4, so we will have 19 over 225. Alright? So far so good, yeah? So our final example here. What if I have a bigger number here? 3.57 and the recurring decimals is on top of 7. Okay, so our first step is let x equals to 3.57777 and so on, isn't it? Next, 10x. So we need to times 10. So it will become 35.7777. Okay, so these two equations we cannot get the same at the back, right? So it means we need to keep on doing. 100x is, so times 100 for the first one. So it's 357.7777. Yeah, so from here we know that the second equation and the third equation we have 7 at the back, okay, which is the same. So it means we can cancel it off by taking it. 100x minus 10x will become 90x, right? Then 357.7777 minus with 35.7777 we'll have 322. So our answer is x equals to 322 over 90. And if you use your calculator, you will get 3 and 26 over 45. Alright? So, the above are the ways to convert recurring decimals to fractions. In fact, it is very easy to understand, right? Well, I hope you all can learn something new from this video. That's all for our video today. If you like our video, like it, share it among your friends, and most importantly is subscribe to our channel so that you will keep updated on our upcoming videos. I will see you on next video. Take care. Bye bye.